All right, good afternoon, everybody. Welcome to the SEBS virtual learning experience, an oceanographer's perspective on offshore wind energy and our ocean planet. Dr. Josh Kohut from our Marine and Coastal Sciences Department will be presenting. Just a few things beforehand. Everybody's muted and your cameras are off, but you can enter your questions into the Q&A section at any time during the presentation. And following Josh's discussion, we will answer the questions in order. This video will be recorded for subsequent posting and viewing. Okay, and just a little bit about our presenter. Oh. Okay. Dr. Josh Kohut graduated cum laude in 1997 with a BS in physics from the College of Charleston and earned his PhD in physical oceanography from Rutgers University in 2002. Since then, he has been a central player in the Rutgers University Center for Ocean Observing Leadership, serving in several capacities, including technical director, and now as a member of the faculty leadership. Using networks of ocean observing technologies, his research and extension programs focus on the physical ocean processes that structure marine ecosystems. He has developed relationships and partnerships across stakeholder groups to ensure his work is collaborative, relevant, and informs applications, decision-making, and management of ocean resources. His projects range from coastal processes impacting storm intensity, beach water quality, and fisheries habitat off the coast of the Mid-Atlantic to regional scale questions centered on marine ecosystem dynamics within the coastal seas around Antarctica. So with that, I will pass it over to Dr. Kohut. Take it away.
All right, thank you, Brian. Can you hear me and see my slides?
Certainly can.
Great. Well, thank you very much for inviting me to talk as part of this program. I am an alumni of SEBS and really proud to still be working with the Rutgers community and a lot of this research that really allows myself and the folks working with us to expand our perspective from just thinking about ocean science or ocean applications to thinking about questions that really bridge a lot of different aspects of a topic for this, which is offshore wind energy. And I'm going to start with kind of a global view. And so about 2 years ago now, approaching almost 3 years, the international community in the form of the IPCC, or the Intergovernmental Panel on Climate Change, has issued a series of reports. But one of those reports issued in October of 2018 talked about this specific metric of limiting warming associated with climate change to 1.5 degrees Celsius above the pre-industrial average global temperature. And they have a few key messages listed here about how we're already seeing the effects of climate change on not just the ecosystems, but on our own livelihoods and people around the world. And those impacts are felt differently depending on where you are. They talk about a global effort to reach this lofty goal of limiting the warming. And they specify the dangers of not adhering to this and at least using some of these specific metrics. And some of these global ideas have been brought locally to New Jersey. This is a report that was issued by NOAA, where they looked at each state individually. In this report, they talked about temperature changes in New Jersey that have increased by about 3 degrees Fahrenheit in the last century. And that's a pretty consistent trend. Precipitation was less of a trend. It was much more variable. And sea level is of great concern to this area as we're seeing unusually large increases in sea level in this region compared to other parts of the world. And so from this perspective, we're thinking about how this global climate question is impacting us more locally. And I went to my favorite state climatologist, Dave Robinson, who puts out a lot of products that are very valuable when we start thinking about climate scales and how it relates. And this is one example of the products that he's put out that looks at the occurrence of extreme temperature months. And so the x-axis is time. You can see it going from 1895 to today. And the months of the year are going from January at the top of the plot to December at the bottom of the plot. And what this is showing is the occurrence of the warmest to fifth warmest month for each month of the year. So January, you'll see there's 5 red boxes going from darkest to lightest. Those are the 5 warmest months. And then the same for the coldest. And what you can see is this general trend of more extreme cold months earlier in this time record and more of the extreme warm months in the latter part of this time record. And so we're seeing these effects of climate locally in New Jersey. And while not the topic of this seminar, so to speak, but it's a context that I want to raise awareness to. And I also want to raise attention to a great resource that's now available, the NJ Climate Change Resource Center. The web link is below. And there is a lot of great content on this site that speaks to specific impacts and considerations in many, many different aspects of life in New Jersey, from conserving different parts of the ecosystem to economies, coastal and throughout the state. And it really does a nice job of presenting that material. The one aspect that's relevant to what I want to talk about today is when we think about where we're getting our energy from and what impacts that might have on climate. So this is a report visuals that the New York Times put together that shows the last 20 years where the power in the United States is coming from. And so the colors here represent sources like coal, natural gas, nuclear, and then some of the lines that are further down in this plot are things like hydroelectric, wind, solar, oil, geothermal. Those are some of those other sources. And what I want you to notice is that there's been quite a bit of change in the relative percentages of where the United States as a whole is getting their electricity or energy from. The other thing that I want to point out is, and topic of today's discussion is wind. And you can see this rapid increase. There's no other category of source of electricity that's seen as much growth in the last 3 years as wind. And in the US, that's predominantly been onshore wind. But you can see this increase in that. If we look at New Jersey has undergone similar changes. There was, with the decommissioning of Oyster Creek, you can see a change in the relative contribution of natural gas and nuclear. The yellow bar there is solar. And what you don't see is a big contribution from wind. There's actually no contribution from wind, according to this data. And I point out a recent strategic plan that was issued by the state of New Jersey. The New Jersey BPU issued this report in September of 2020, and it lays out a plan to transition New Jersey to be in a position to get up to 50% of its anticipated load in 2035 from offshore wind. There is a goal of 7.5, that's supposed to be a GW for gigawatts, of offshore wind, which would be, as I said, about 50% of the load. And so there's a lot of work that's being done to explore offshore wind as a renewable energy source to the state, and frankly, further out beyond that. I'm going to focus on the state of New Jersey here. And there's a couple reasons for that. The first thing I want to point out is just some general statistics or features of offshore wind. By offshore wind, we do mean turbines that are being constructed in the ocean, away from the coast. And so there are advantages to that in that existing land use and considerations for overlap with other land use is not an issue. It also brings some challenges. There's different engineering and logistical requirements to construct something offshore and to maintain things offshore. To date, there are 2 offshore facilities in operation in the United States. The first is Block Island, which has 5 6-megawatt turbines. This picture on the right is showing those turbines. It's providing 30 megawatts of power back to the island of Block Island, replacing what was delivered before through generators on the island. And excess power is getting delivered back to the grid on the mainland. There's also, within the last year, 2 turbines that have been deployed off the coast of Virginia as part of Dominion. These are, again, 6-megawatt machines that are currently being used as a test bed. And so when we think about offshore wind, we need to not only consider the technical and the engineering pieces, but there are other things to consider. And I'm going to offer my perspective on the ocean characteristics. I am fascinated by the ocean. It's an area of my specific research for many, many years. And one of the aspects of the ocean that fascinates me is how dynamic it is, and that you can't think of the ocean as a single blue volume of water. There's incredible structure and complexity in the ocean. It's changing from minute to hour. Any time scale that you want to consider is going on in the ocean. And so when we start thinking about developing a technology in this highly dynamic area, it raises a lot of interesting science questions. There's also not just offshore wind that's slated for these areas. There are, even though we don't live out there, there are many other users of this dynamic ocean environment that are considered as we come up with a responsible way to deploy this new technology in the region. And so why the Mid Atlantic Bight? What is so special about our particular part of the country? And there's a few reasons that make offshore wind very advantageous in our area. One is all of you and me and all of our friends and neighbors and families that live in this area. There is a huge portion of the US population that lives in the I-95 corridor between Virginia and Maine. And so there is a demand for energy due to that high population that is closely located with the offshore areas of the Mid Atlantic Bight. You can see this. This is an image at night, and you can see that clear electrical demand in this corridor and how close it is located to the ocean. So the other thing that makes it particularly advantageous is access to the wind resource. We are getting energy with these systems from the wind, and so reliability and persistence of that wind resource is a really important aspect of delivering reliable energy to that demand that I just shown. And so this is a map of the wind resource put out for the whole country. And what you can notice in our area up here in the Mid-Atlantic is that the higher wind resource, indicated by the hotter colors here, the reds and oranges, is located offshore. And onshore, the winds are much less advantageous for energy extraction. And so that boundary, this is not a mask that was put on this data, but that coastal boundary is a natural delineator of a very different wind resource offshore compared to what's available onshore. And so because of this, and I forgot to mention, this is a map showing the bathymetry. And one of the other areas that makes this a really advantageous part of our country, in addition to having wind resource, in addition to having a demand for the power, is that the topography or the bathymetry of our area is a very broad and shallow shelf. And so we can go 100 miles from the coast and still be in water that's less than 500 feet deep. That's very unusual. On the West Coast, you could do that by throwing a stone off the beach practically. And so the fact that there's relatively shallow water extending far from the coast makes it more technically feasible to deploy some of these turbines, particularly those that are deployed secured to the sea floor, either through jackets or monopiles or gravity foundations. And so the states in this region, not surprisingly, are setting goals for developing offshore wind as a contributor to the power that's required for their citizens in each of these states. And this is as of June of last year, the commitments that I'm aware of that each state is advertising. And for New Jersey, you can see that 7,500 megawatts or 7.5 gigawatts that I mentioned earlier in this presentation. To date, there has been 1,100 megawatts of that awarded to Ørsted, who is developing a project, Ocean Wind, which I'll talk about in just a minute. And right now, there is a second solicitation for the state of New Jersey that is considering anywhere from 1,200 to 2,400 additional megawatts of power. And that process is currently underway. Announcements are expected in June for how the state plans to go forward with that. And so when we think about some of the environmental considerations for offshore wind as it gets deployed, and again, I'm going to focus on that aspect of it for this webinar, there is a process, and this is the federal process that's put out by BOEM. Those of you who are familiar with offshore wind have probably seen this slide before. And it goes through the steps from the initial plan of identifying areas that might be appropriate for offshore wind development on to the installation of the actual turbines on the right. And there are different steps and there are different opportunities for science and for stakeholders to contribute and influence how the development actually happens for a particular wind farm facility. And there are right now a large number of projects that are in various stages along that timeline. That timeline can last as long as 10 years or more. And so you can see from this map on the left, some of the areas that have already been leased for offshore wind projects. And each of those are in different stages of development through that timeline. And given that, there is an opportunity for myself and all of the researchers at Rutgers to participate and ensure that the science, the latest science is available and considered as these facilities begin to move through that federal process and equivalent state processes that I didn't even share. And so we put this together, we being the larger Rutgers community, several years ago to highlight the breadth of expertise that Rutgers has to offshore wind, from the economic policy integration with existing electricity markets and grids, to the actual design, manufacturing, supply chain issues associated with the turbines or cabling or transformers, all the different components of an offshore wind farm, to the environmental considerations, which is where I'll focus a lot of my presentation remaining on. But the other important aspect that I want to bring is the center of this circle. And that is the social economic side, particularly related to workforce development, engagement with the communities. That's a really important role. And Rutgers, as a land grant institution with a whole breadth of knowledge on this, has this conduit that I think is really critical to advancing this and ensuring that the science that's being done is relevant and that the science being done is also contributing to this. And so I'm going to speak a little bit about that as we move through. So this is where I get to work. It, of course, doesn't look like this because this is incredibly irresponsible during a pandemic. But normally, it would look like this with a observatory of the ocean and the atmosphere above the ocean that's running 24/7. And even during a pandemic, it's still running. It's just there's a few less people in the room than what you see here. But it's an observatory that allows us to do science, allows us to think about some of these applied questions, and to do it alongside our students. And so it's important that the students are engaged in the research that's done. They see the relevancy of the research. And so offshore wind provides an awesome opportunity for us to explore some of these important questions that has direct relevance to decisions that are being made. And in addition to the people, we bring technologies to the forefront to this question. And that's done through satellite systems. I show a CODAR network, which allows us to map ocean currents, and underwater robots, which I'll talk a bit more about as we go through. And we call them gliders. You can see an image on the lower left there of a glider in the water, and then the picture of the lab there on the far right showing gliders in various states of readiness for deployment. And so what these tools allow us to do is to measure that dynamic, interesting ocean environment in a way that's relevant to some of the questions that are being raised and some of the environmental impacts that could happen with a deployment of an offshore wind farm. And I'm going to just walk you through a couple examples of how we are applying this ocean observatory to some of the questions. And I'm doing this as again, from my perspective as an oceanographer, and I'm in no means saying that this is the only activity that's going on. From that prior slide, I want to make sure that I stress that there is a lot of communication that's being done through various groups, a lot of opportunity for Rutgers to participate in this process and to deliver the science, again, to the decision makers that are making these critical decisions. So the first aspect I'm going to talk about is a project that we started with New Jersey Board of Public Utilities over a decade ago, and that was to understand the wind resource. And so we have a mid-ocean monitoring site near our field station in Tuckerton, New Jersey. You can see the location there on the left, the map with the red arrow. And it has a observatory for the immediate atmosphere above this particular site. We have a Met tower with sensors. We're working with Dave Robinson and his Mesonet. Also another company, Weatherflow, that's doing hurricane hardened systems are being tested in this facility. There are also profiling systems. The SODAR is shown on the left, which allow us to take profiles of the wind so we can determine not just the wind above the ground, right immediately above the ground, but also up into the atmosphere. And there's also a scanning LiDAR system, with a FLIDAR, not a FLIDAR, a scanning LiDAR that allows us to map the wind fields vertically and horizontally. So we can extend the reach of this monitoring site out over the ocean, overlapping with some of the areas being considered for offshore wind. So this mapping is getting fed and used to validate a atmospheric model that we've continuously run since 2011. Each day it's run. Dr. Joe Brody in our group is responsible for this model and all the products and analysis that come from it. It's a nested system that narrows down to the New Jersey scale at fine horizontal resolution. It provides hourly estimates of atmospheric parameters, scalars like temperature, relative humidity, but we also get winds at various heights above the ground as well as out over the ocean. And so we can use this model for a variety of analyses relative to offshore wind. Some that we've done so far, think about large timescales. So the map on the left is the mean wind speed for 3 years of model simulations at 120 meters, which is approximate hub height at the time we did this for the turbines being considered. And so we can start to map out some of these fields relative to the planning and existing lease areas slated for offshore wind development. And the one thing that's unique about this model is it benefits from all the ocean knowledge we gain from the observatory that I showed you a few slides ago. And so we want to make sure that the knowledge that we have in terms of our observatory of the ocean is making its way into the atmospheric model, because the two systems are very coupled. You can't consider the winds over the ocean without considering what the ocean is doing beneath. There are processes like upwelling of cold water that impact sea breeze circulations along the coast. And these processes like sea breeze or storms as they come across have scales that are relevant to the offshore wind. And so you can see on the right, that's a wind map. The wind speed is colored on the right on a scale of meters per second. So if you're more familiar with knots, roughly double it. So the red areas are around 30 knots. And did I do that right or I have it? Sorry, brain fart there. So what we can see is the spatial details of the wind fields and how that structure is at the scale of those wind farm facilities. And so we can, by bringing in the ocean information, we can actually more accurately replicate these processes and consider them when we're looking at the wind resource, whether that is the wind resource on a scale like a 3-year mean or a 1-year mean. That's valuable to understand what potential power might be delivered from a utility scale wind farm in this region, or it could be a next day, what are the winds going to be like, so we can anticipate what power might be delivered to the grid. And so these forecasts become really valuable in terms of assessing that wind resource, understanding what it might be on a whole host of timescales. And we thank the BPU for their support of this, because it allows us to look at the importance of processes like sea breezes or occurrence of nor'easters, and how that might impact the reliability or the delivery of power from offshore wind farms. And so going back to our timeline here, one of the other things that is critical are many opportunities within this, whether it's in the pre-survey plan for a particular site once it's leased, to the construction and operations plan that gets submitted. There are environmental considerations, there are impact analyses and different surveys that are done. So there's a lot of opportunity for the public to participate in that process. And Rutgers has been active in that area, and we have used that opportunity to learn more about what some of the research questions are. And one community that's been particularly involved in that is commercial and recreational fishing, because they are very curious about what offshore wind might mean to their own industry and the way that they have accessed the ocean for their careers, and what might change in offshore wind. And so there are questions that are being raised, and the offshore wind and fisheries are particularly related because they're, as I said, they're working in the same area. And we have a dynamic system like an ocean. You put on top of that the ecology that's linked to the physical ocean and how dynamic that is. And it raises some important questions and concerns from this community. Thinking about access to fishing grounds that they may not have going forward, or what cabling or infrastructure on the seafloor might mean for dredges. And there are many others at Rutgers much more familiar with the details of this. I bring it up because I'm interested in the research that's linking the physical ocean to these ecologies and how we can understand how dynamic habitats are and how that might be influenced by offshore wind. And so these are some of the questions that are being raised. And through these dialogues, these are some of the research priorities that have been identified. And I'm going to focus on the ecosystem impacts. And what we're thinking about is how coupled the physical ocean is to the ecological ocean and how dynamic it is. How can we use our knowledge of different aspects of those systems to think about what impact might occur when we put wind farms offshore, for example? And these are questions that are being raised by the community that Rutgers and others in the region have a unique opportunity to address. And so one particular area that's come up more recently in the last year has been thinking about something called the cold pool. And I'll introduce that to you here, that the Mid Atlantic Bight is beautifully complex. This is my job security, right? It's got horizontally a lot of interesting things come together in the Mid Atlantic Bight. The plot on the left is an image of sea surface temperature. So the reds are warmer water, the purples are colder water. And in our region, we have this awesome convergence of warm tropical waters in the Gulf Stream, which is labeled as a boundary current there, coming from the south. We have colder polar originated water masses that are coming down in the terms that purple arrow up high, the purple water coming down, that's Labrador water that's coming down. There's influences of the watersheds. We have the largest estuary in the US, in the Chesapeake Bay in our region, Delaware Bay, Raritan Bay. All of these important estuaries, Long Island Sound, are contributing fresh water and other parameters to the coastal ocean. And it's all coming together in this area. And one of the things that's particularly unique, that's related to the fact that the ocean is so shallow off our coast, is that we have a feature that forms every year and goes away every year called the cold pool. And essentially that is the cold water from right now. Right now the water's cold out there. We have proof. We've got a robot out. But it's about 40 degrees right now, the water. And that cold water that's off our coast right now is going to remain along the bottom of the ocean through August. So even though July, August, you might enjoy some times down at the beach, surf temps are pretty warm in the 70s. That's this map on the upper right. This plot is showing this cold pool. So this is a summertime condition where only the surface of the ocean warms up in the summer. The bottom water stays cold. It stays January, February cold. And what happens is, over time, this pool of cold water moves around. It moves towards the coast and away from the coast, depending on wind. It moves up and down the coast. And so it literally is this volume of cold water that not only has impacts on the winds, but it has impacts on the ecology. And so there are a lot of questions that are coming on what impact might offshore wind have on this important feature called the cold pool. And so Travis Miles, Sarah Murphy, Sarah Borsetti, and Daphne Monroe and myself, with support from SCEMFES, did a full literature review in response to this. And we're asking questions like, what happens when a utility scale wind farm gets deployed to what happens to the cold pool? What happens if multiple wind farms are deployed? Well, there's a few key questions, and we outlined it in this report. Travis was the lead, and we think about, the overlap between the cold pool. We think about the threshold of stratification that could be impacted. These are all important questions. These are questions we have the tools and the means to answer. To show a little bit more specific about it, this is a schematic from a paper from our colleagues in Europe. So Jeff Carpenter and his colleagues put out a paper that looked at what the effect was of a single wind turbine on the stratification that they see in the North Sea. And so this schematic here is from his paper. It shows this is stratification. So this is showing that there's a lighter dense water, a lighter in terms of density water mass above, below, more dense. And what happens when the tides move this stratification past a turbine? What's the effect of the mixing? And so we have some initial work that's been done, but this work hasn't been done in the context of the cold pool. Cold pool is quite unique. And the stratification varies depending on if you're in the spring when it's forming, in the summer when it's really strong, or in the fall when it starts to break down. And so these are the kinds of questions that the oceanographers are considering when we think about offshore wind. The final example that I'm going to give is perhaps more relevant to the construction and the operations. And this is a consideration of marine mammals. And so the northern right whale is a threatened species in our region. The number of individuals is in the 300s on the planet, and they go through a seasonal migration that overlaps with the offshore wind planned areas. And so there is a big interest among all those involved in offshore wind to identify ways to really minimize the impact of offshore wind development and operations on the northern right whale. And I'll say there are many, many anthropogenic impacts on right whales that go far beyond the introduction of offshore wind. Ship strikes, entanglements. Some of these are ongoing with these particular animals, and there's a huge effort to try and monitor and prevent impacts to any individual in this population. And what we are doing is considering how we might bring some of our tools in the form of underwater robotics, moorings, to monitor and better understand the habitats or the selectivity that these animals might be using in their behaviors as they move through areas considered for offshore wind. And so it's thinking about what some of the acoustic impacts might be as turbines are being installed, and as well as during the operation. And so we have begun a very exciting project in the last year, funded by Ørsted, one of the developers, and this is the developer that was granted the award of the 1,100 megawatts for the Ocean Wind project, which is currently the only project that's approved by the state of New Jersey. And like I said, there's another tranche that's being considered that will be announced in June for an additional 12 to 2,400 megawatts. But as part of that project, we've begun a program that partners with Woods Hole Oceanographic, Mark Baumgartner's team, and Jim Miller at the University of Rhode Island to explore ways in which we can use fixed platforms like buoys, as well as mobile platforms like our gliders, to look at ways that we can protect and conserve northern right whales over the lifespan of an offshore wind facility. And so this has a few aspects to it. One is just the monitoring. And there is a growing network of monitors throughout the region that are continuously detecting through acoustics, passive acoustics, the presence of marine mammals, particularly the northern right whale. And 2 days ago, or 3 days ago, we deployed our next mission. So as part of this project, we are deploying one of our underwater gliders equipped with multiple sensors that allow us to measure the ocean conditions from the physics all the way up to these marine mammals. And so here's Nicole Waite, one of our glider engineers, and she's battling the cold. Fortunately, we found a window with relatively light seas, so we could get this glider deployed on Monday afternoon. And the map on the left here shows the path that this robot has taken since we deployed it on Monday. And so it's made its way across the wind energy area. It's going back in. This green marker here is showing the location of our buoy, the Woods Hole Oceanographic Mark Baumgartner's buoy that has similar sensors on it. And so one of the sensors on here is what we call a CTD, which allows us to measure the temperature and salinity of the water. And I show that data here. So this robot is still out patrolling. It's giving us a phone call about every 3 hours along the mission. It's sending that data back. And so we're seeing information coming from this robot. And while I'm talking to all of you, this robot's out there doing work for us. And so we're getting a estimate of in this case, I'm showing salinity, so fresher water here near the coast. And as it's making its way offshore, it's getting into saltier water. And at the same time, it's listening for whales. And so since we deployed on Monday, we've heard from right whales and fin whales, and we might have heard from a humpback. This has not been confirmed yet. We still have to do some additional work to confirm that that was actually a humpback whale. But we have confirmed right whales and fin whales. And what I'm showing here is where in this salinity record we heard from those particular species. And so what we're doing as another part of this is we're starting to try and look at what are the environmental variables that might predict where these animals are. And so what we're doing right now is we're collecting the data. So we can see the right whale was heard here near a salinity front. Could be coincidence, it could be not. We have to look at this much more deeply. And then the fin whales were all heard further offshore in this area. So this is an example of how we're using the technologies to monitor the entire system from the oceanography up to the marine mammals in a way to better understand these animals so that we can inform the responsible deployment of offshore wind in a way that minimizes the impact on these species. So it's an exciting opportunity, and networks like this are going up throughout the region, and information is getting shared in real time with these tools. And so in summary, offshore wind is coming. It's coming to the US and it's coming to New Jersey, and there's quite a bit of activity. It's being deployed in a system that's very complex. And there are many stakeholders that have expertise that can contribute to the responsible deployment, and Rutgers is at the forefront of that. I gave some examples, and there are many, many more of ways in which science being conducted at Rutgers can be used to help inform the decision-making associated with offshore wind. And so I'll thank everyone for your attention, and my email is there, and as well as a website if you would like more information.
Thanks, Josh. We do have a few questions.
Sure.
Okay. Someone would like to know, how will the ocean wind turbines affect bird migrations?
Yeah, so it's an important question. It's outside my particular area of expertise. I can say that there are groups that are focused on monitoring the typical migration routes of seabirds that are further offshore, also some bat species that are out there. And when they go through that 10-year process that I showed, there are multiple steps where those data and the latest knowledge of those particular species and timing of migration, location of migration are being considered in where those wind farms are being leased. And so that is part of the environmental assessment and the impact analyses that are required as part of the permitting. It's just outside of my expertise, so I couldn't speak more on what those impacts are and what the level might be.
Okay. Another question, has the offshore wind modeling allowed for a projection of capacity factor for the proposed wind farm?
Yeah, and I didn't get into that, but we do that. We are able to do that. So we can take the winds that are coming from the model. We can also take what we know about the turbines that are likely to be deployed in different facilities and translate that into capacity factors and look at how that capacity factor varies in time. You know, what might impact that capacity factor based on the model. So yes, that it's important that we go from winds to capacity factor to the power that will ultimately get delivered. And we've partnered with groups at Blaustein to actually take the winds estimated from our model and stick them into some of the economic and energy modeling that's being done as a more realistic input into their work.
Okay. Another question. Your data show varied wind speeds up and down the Mid Atlantic Bight. What is the relationship of wind speed to power production? That is, for example, hotter wind speeds further north than the mid to south Jersey coastal area, which is yellow, versus the red to the north. Is the power production linear with wind speed? Or another way to ask is whether the conditions off the Jersey shore are less than optimal compared, for example, to those in Massachusetts or Rhode Island?
Yeah, good question. It's not linear. It's actually cubed. So the power is the cube of the wind. And so understanding the details in the wind field is important. I will say that while there are differences in that map between, for example, the lease areas that are being developed off of Martha's Vineyard and Nantucket compared to what's off of New Jersey, compared to what's off Virginia, there are some subtle differences. Those are all being considered in the development of those different projects. But I will say that in all areas, the wind resource offshore is much more persistent and reliable than what we see onshore. And so those considerations are part of the decision process, and understanding what the wind, the energy provided by these facilities will be. Okay. So yes, there are some differences, and that's why we're using this model to try and understand what those differences are. But the input that we're providing back to the state and to the different stakeholders that we're working with are considering those differences. Okay.
When hearing these species with your robot, how far can they be from your sensor? Sound travel far underwater. So wondering about the person's wondering about the correlation between the salinity and sound records.
Yeah, so that's really important. That's another benefit to us measuring the temperature and salinity. We can get an estimate of range of the day, for example, because it will differ from day to day depending on what the temperature and salinity conditions are for how sound travels and how far. But in general, and it depends on how loud the whales are, of course. But in general, it's around 1 mile to 5 miles is the range for many of the marine mammal species. And we have another sensor on here that many researchers in the area, we've partnered with University of Delaware on a lot of projects looking at tagged fish and movements of tagged fish, where fish are actually caught. They get a transmitter surgically implanted, and then we can track with listeners. So this glider has a listener, and in that case, the fish have to be much closer, within about a half a mile to a mile for that to get detected by the glider.
Okay. Another question, why are there so few offshore wind installations in the US?
Wow. So I don't know the whole history. I can only say that there's a big effort right now among, not just in the Mid-Atlantic, but around the country, looking at how renewables like offshore wind might contribute to the energy demand. We benefit from the fact that our colleagues in Europe have about a 20-year head start. And so I see that as an advantage. I can't answer as to why that happened, but the fact that it did happen gives us an opportunity to benefit from that experience and make sure that things are done given what experiences have been gained from other installations in Europe.
Okay. Another question, do you have an idea on the lifespan of the offshore wind turbines?
So, the developers will be able to answer this much more specifically. My understanding is that most of the planning for these facilities is for them to operate in the 25 to 30-year range. And all of the plans that are submitted for permitting have to include not just the construction and operation, but also the decommissioning of those facilities. And so the first wind farm that's been decommissioned in Europe, it was deployed in the early 90s. That was as I am aware, that's the first wind farm to be decommissioned, so that's about the time frame. So it's consistent.
Okay. Another question. A lot of negativity relates to what happens to the physical parts of the turbines when they are no longer functional. Salt water is very corrosive. What leaches off in the ocean, and what is that impact of that?
So I'm not familiar with the each of the projects are proposing what they feel are the best, technically minimizing environmental impact systems to deploy. The wind farm off Block Island was deployed with a foundation called a jacket. It looks almost like a radio tower, right? That they're sitting on. There are other projects that are being proposed that are monopiles, a simple but huge structure that goes down into the sea floor. Another project is considering gravity-based foundations that will just rest on the sea floor. And so the materials for these, the maintenance, are all considered in the permitting process. And I can't speak to the details of what is advantageous, what minimizes impacts on the environment, but I know that those reviews are all part of the process. And so the developers and the engineers and the the folks that are putting those proposals together have to include all of that information before those permits are issued.
Okay. Another question. Has anyone started work to address the combined cumulative ecological impacts of all wind farms along the East Coast, particularly in a fisheries context? For example, how might north-south migrating fishes be impacted by wind farm installation along their migratory corridor?
Yeah, really important question. And it's recognized as an important question. It's also a very difficult question to answer. But the community is doing that. There was a recent environmental impact statement that was issued for the Vineyard Wind project off of Massachusetts, and it had a requirement to consider cumulative impacts. And so there was a significant portion of that document that was focused on cumulative impacts and what we know. This past November, there was a workshop sponsored by the research consortium, NYSERDA, that was focused on cumulative impacts. And there are work groups that are forming from that initial workshop in the fall. And our own, I know Doug Zemeckis is involved in the organization of that as part of the cooperative extension piece of what we're doing. And other researchers here at Rutgers are involved in various work groups associated with that. So it's a very important question. It's one that will take some time to address and answer, but it is being considered.
Okay. Another question. What is the sound signature and footprint for each wind turbine? So
there's two ways to answer that, and I am going to say that I can't answer either of them, but I'll frame the question because I don't know the answer in terms of like quantifying the exact noise level, for example. But there's two time periods to consider when we think about noise impacts. The first is in the actual construction of the wind farm itself, and so that tends to be more acute. It's directly related to the installation of the monopiles into the seafloor, for example. Those tend to produce noise. They do produce noise, and it's important for that time period to be monitored. And we're considering our gliders and trying to demonstrate the value of our gliders to be tools in that, because they can monitor and detect whether there are species at risk in the area before that work is taken on. The other time frame that's important considering that question is in the actual operation of the wind farm itself and the noise that may be generated by the turbine spinning. And so that is less that would be in my understanding, less acute and more chronic, but at a much different level, decibel level than what you would experience when you're, for example, driving a monopile into the seafloor. And so both of those aspects of a project are considered. And I know there is research that's underway that's looking at what those noise levels are. There are various mitigation, for example, like bubble netting around a facility as it's getting installed to try and minimize those impacts. But that's an active area of research. And again, we learn from some of the things that are being done in the European installations to help inform what we might do here in the US.
Okay, just a couple more questions. I think we'll do two more. What about the massive blades when they're retired? There have been publications and articles on this lately, much related to land installations, but what happens with the blades when they're finally retired?
Unfortunately, I don't know the answer to that. I would assume that would be in the decommissioning plan that would have to get submitted for the permits. And so the decommissioning is, as I understand it, it's restoring the the site to what it was pre-construction. And so the disposal or recycling or whatever is done for all the components of the wind farm would be included in that plan. And I don't know what those different options are. It's outside of my area of expertise.
Okay. Final question. There's been some discussion about onshore impacts of the offshore turbines. Do you want to touch on that a little bit?
Yeah, there's been, well, the part that I am familiar with are questions raised about what impact the wind farms themselves might have across the beach when we think about different weather patterns and things like that. And there are research that have been done to look at what the reach of impact is of a wind farm. For example, how far downwind do you see the effect of a wind farm, and how that might relate to winds that are available or humidity, some of these parameters that are associated with our weather. And from what I have seen, the impacts of the wind farm are felt to within about 10, a maximum of around 10 heights of the individual turbines. So if you think about, a turbine, it's something that's within a few miles to maybe 10 miles of the wind farm, given what's currently being considered for deployment. And so there may be impacts there. We have to explore those. It's actually, in some of our discussions through RCE, it's been thinking about, what is the ocean's influence on our weather? And, we've looked at sea breezes, and I think the compelling questions are more, how far inland does the ocean influence weather in our state? And what are the times when it does so more than others? And then think about what impact a wind farm might have on that. And there are recent papers that came out from, I know one paper in particular from our colleagues down at University of Delaware, looking at, specific situations where the winds are moving onshore and how that might impact some conditions right along the coast. And so, yeah, it's a good question. Still a lot more research to do in that area.
Thanks, Josh. You can unshare your screen now if you'd like.
All right.
Okay. I just want to thank Josh, Dr. Kohut, for joining us for the SEBS virtual learning experience today. I want to thank you all for joining us. Thank Mary Nucci also for help in putting this together. I'm Brian McGonigal, Manager of Alumni Community Engagement for SEBS and the Agricultural Experiment Station. We will send up a follow-up email, which will include Josh's contact information if you would like to ask him any further questions, and also a link to the video when we get it posted. If you can, please join us on Monday. We're kicking off our virtual Science Cafe series. Dr. Mala Aronson is going to talk about biodiversity in the world cities. And that will be at 11:30 on Monday. You can find information about that on the SEBS alumni events page. And you can reach out to me with any questions you might have, just brian.mcgonigal@rutgers.edu. Once again, thank you so much for joining us and have a great day. Take care.
Thank you, everyone.